Hello guys and welcome to my new video. Do you hear that sound? That's a metronome ticking. Yes, today we will be making a metronome in Blender. We will make a quick model of the metronome itself, then add some drivers to the needle to make that swinging motion, texture it, and set up the scene for render. Now without any further ado, let's get started. So let's scale down the default cube to 0.13 meters square and 0.22 meters on the height. Let's move it so it touches the floor on the bottom. And let's scale down the top face, then extrude it again and scale it once again. Now add a loop slice, select the front face, insert it in and extrude it inwards. Now add a loop cut on the inside and on the outside, select these three faces and delete them. Now let's build polys. I actually didn't have assigned a shortcut to build up polygons from the vertices, which I now fixed, and now I have it assigned to a P key. So let's finish with building of these 6 polygons, and now let's move these edges a little bit outside. Separately the top edge, let's change the view from the y-axis and fine-tune the position of the vertices. Now let's create a pocket for a needle, so insert this face, scale it down and extrude it inwards. Now let's rename it to Metronome Body and add another cube and scale it down to 1.5 millimeter thickness, 3 millimeters width and 18 centimeters height. Move it upwards and position it inside the pocket. Now from the front view, let's hide the Metronome Body, extrude the bottom face with 3 millimeters. And now let's add the loop cuts and scale it outwards so it resembles an 8-gon. Now select the 4 front faces and 4 rear faces, insert them, then scale them down proportionally so it resembles a circle. Now let's hit bridge tool and finally scale down the top face so it has a taper. Now we can add a bunch of loop cuts. I don't think that I will add a subdivision surface modifier, but anyway I will set the needle to smooth shade it, so the loop cuts will create actually a nice round edge even with this low poly configuration. So let's set shade smooth, and now let's add another cube. This will be our metronome weight, 3 millimeters on the X, 2 centimeters on the 1.5 centimeters on Y, and 1 centimeter on the Z axis. Let's position it, and let's also reposition the needle and copy the X location and paste it to the metronome weight. Now let's modify the weight, so select the top part, scale it down to create a taper. Now select the top and bottom face, insert it and scale it down so it touches from the outside the shape of the needle. Separately the bottom face, and now actually we can select both of them and bridge them to create a hole. Now again add a lot of loop cuts to create a nice smooth edges when we shade it smooth. So this is pretty much everything from the modeling part, and as I told you, you can download the finished model from the link below, and we can start actually the work on the rigging part. Now we actually have the center of rotation in a wrong part of the model, so we have to fix that, and we need to position it to the hole that we created. But unfortunately, we cannot easily do it from the object mode. What we have to actually do is we have to go to edit mode, and we will first position our 3D cursor to the selection. What we have here is the edges that create that sort of a target. So let's actually select these 4 edges from on the front faces and also on the rear faces. And now we will select mesh, snap, and cursor to select it. This will center the 3D cursor perfectly to the center of the polygons or of the selection. Now let's go back to object mode, and now we can object, set origin, and origin to 3D cursor. Now we have the center of rotation where we want it. So this is how it should behave. Now let's also reset the position of the 3D cursor. So object, snap, cursor to world origin. Now let's unhide the metronome body, and let's actually rename the object. So this will be metronome weight. The other one will be metronome needle. And now actually we will create a hierarchy. So let's parent the needle to the metronome body. That created this sort of a tree, and now the weight to the metronome needle. So first select the weight, then the needle, and hit P key as a parent and select to object. Now we have a full hierarchy, and wherever we move the body, the other parts will follow, or when we rotate the needle, the metronome weight will follow the rotation of the needle. Now we actually need to fix the position of the weight a little bit, because it's now it's going actually inside the slot, which we don't want. So we will increase it to 0.09 meters, 9 centimeters, and now it looks okay. So the first thing we can do to animate it is to insert actually keyframes that go from 20 to -20 degrees. So now we have inserted the first keyframe. Let's move the timeline to frame 30, right here -20, and right click and insert keyframe. Now we have a first animation, but obviously after the frame 30 it does nothing. We will definitely not add the keyframes manually. Let's actually go to animation tab, select the metronome, hit F to frame it, and let's expand this window and change it to graph editor. Let's select the needle, which we animated, and it created for us the channels that are animated. So we have here the X rotation channel, which goes from 20 to -20 on 30 frames. What we can do to make it move constantly is extrapolate it to linear extrapolation, which will not do what we want because it will spin it constantly. That's good, for example, if you need to animate a ventilator, but for us that's unusable. So let's actually right click it and return it to constant extrapolation. We will add the modifier instead. It will be a cycles modifier, and now as it added by default, it will go it will start the animation and then return it. We actually need to repeat mirrored on both before and after mode, and that will now create our cyclic motion. But actually this is not how we will animate the metronome. So let's delete the modifier, and also let's delete the keyframes. And back in the layout, right click and clear keyframes. We will use drivers instead. Also zero out the rotation, and now let's add a empty cube. Scale it to 0.01 meters to 1 centimeter and move it on top of the metronome body and parent it to the metronome body. This will be the selector for the user, where he can set the parameters of the metronome animation, namely a BPM. So let's rename it to metronome control, and in the object properties, let's add a new custom property. This will be BPM. Integer type, default value will be 40, maximum 208, minimum 40. Okay, And let's also add another one. This will be our frames per second, FPS. Default value 25, minimum 1, maximum 120. Click OK. And let's actually set the actual values for BPM 40 and 25 for the frames per second. And let's also check the settings of the scene so that it matches our frames per second. Now, back in the object properties, right-click the BPM and copy the data path. We will add a driver for the weight, so it goes from the bottom position of 0.09 meters to 0.2 meters on top. Right-click it, add a driver. Now, delete the expression and let's change the variable. It will be our BPM. We have to choose the metronome control object. Actually, it has to be a single property, and the path, let's paste the copied data path, the BPM. Now we can start writing our expression. We will use a linear interpolation for the distance, so it will go from 0.09 to 0.2, and we have actually to use another function, smooth step, that will normalize the BPM from 40 to 208 to a range of 0 to 1. So this is the expression for the linear interpolation, and now when we adjust the BPM from 40, the weight goes up. Actually, it's inversed, because with the low BPM, the weight has to be on top. So what we will do is just switch the two values, so from 0.2 to 0.09. Now when we change the BPM, it moves correctly as it should. Now let's make the expression for the swing of the needle. That will be a frequency, and I will use a cosine function. So let's clear the expression, add a input variable of a single property from our metronome control. Path is the BPM. Let's start writing the expression, cosine. Let's actually rename the variable to vardo to BPM. And also we will need another variable and the frames per second, that we will use it here. So let's add the frames per second from the metronome control and paste again the BPM and just rename it to FPS. Okay. Now the expression will go BPM slash frames per second and also slash 60 as 60 seconds in a minute, and multiply it by current frame and by pi. That's the expression for our frequency. Now, actually, we have already the motion equation. We just need to set the maximum amplitude, which will also depend on the BPM. So the higher the BPM, the smaller the amplitude. So I will add the amplitude to the empty. So let's add another property, name it amplitude. Click OK, and it will be a driven value, so add a driver. And now we will use pretty much the same system like for the weight. So let's add our usual BPM variable. The object will be the metronome control again. Change it actually to single property, and the path, let's paste the BPM data path. The expression, it will be again the linear interpolation, so let's write a lerp, and this time actually it will go from pi slash 6, which is 30 degrees, to pi slash 9, which is 20 degrees. And again, we have to normalize the BPM to a range of 0 to 1. So we will use the smooth step function for the interpolation of the BPM, or to normalize it to 0 to 1. Okay, so and now as we have our amplitude equation finished, we can actually add it to the cosine function. So Let's actually add the variable, again single property of our, let's name it amplitude, and select the metronome control empty, paste the BPM data path and rename it to amplitude. Now actually we just need to multiply the amplitude by cosine, and now the motion equation is complete, even with the limits for the amplitude. Now let's expand the frame range to 1000 and let's play around with the BPM, increase it all the way to our maximum, to 208, and we can see that it increases the tempo and limits the amplitude as well as we increase the beats per minute, the tempo. So this is our metronome rigged and finished. Now let's make a scale. Go to edit mode, select loop cut and make a loop cut on the center of the metronome body. Now select offset edge loop cut and create mirrored loop cuts around the center loop. Now select the phase loops with select next and delete the faces. Now delete the rest of the model, and we will use symmetry on the metronome body. Now let's actually straighten the edge a little bit. So move the vertex on the y-axis a bit closer to the center. Let's look from the front and also move it like that. And now actually let's move the entire edge a little bit inwards so that it's a little bit more narrow. Now back in the object mode, let's apply the mirror modifier and use the y-axis. Okay, now back in edit mode, let's select the face, Ctrl E to extrude it inwards on the x-axis, just a little bit. Now select the central face that's on the mirror plane that doesn't belong there, and now we have let's copy the face, Ctrl D, hit escape, and now separate a selection. That will create us a new object which we will use for the scale itself. So back in object mode, just reselect it and go to edit mode. Select the single face and again hit Ctrl E to extrude it. Now extrude it outwards on the x-axis to be roughly on the same plane as the metronome body. Now deactivate the mirror modifier and delete the face that's on the mirror plane. Now re-enable the mirror modifier, and now let's add some loop cuts to tighten the edges. One on top, one on bottom. Now on the side. And let's hide the metronome body and also make loop cuts here on the left and on the right side. Okay, now we can unhide the metronome body. Go to object mode, right click and shade smooth. And I think we need to tighten the edge a little bit more. So let's get back to edit mode, double click the edge loop, dissolve edge, and just make a new loop cut and make it a little bit more tighter on to the left corner or to the left side. So now turn on the X-ray and let's create a small gap between the body and the scale. Move the top vertices downwards, the bottom vertices a little bit upwards, and now select the side vertices and move them closer just a tiny bit to the center. Now in the object mode, let's turn off the X-ray, and we have the scale inside the body. Now let's make a cover. Let's select the body and go to the object mode, to the edit mode, and select these faces. And on the bottom part, select the faces that are outside of the pocket. Let's Control D, duplicate them, and separate selection. Now we have a new object, and let's rename it Metronome cover. Now go to edit mode, and let's hide the needle and the weight. So now let's actually bridge these edges. So edit bridge, and select these edges and dissolve them. Right click, dissolve edges. Okay. Now let's hide also the metronome body, and select the faces and the top faces, and now let's bridge them. That will create this sort of weird twisting. Let's uncheck the remove faces, and let's play around with the twist and reverse check button until you get a result that looks correct. So now let's actually make a loop cut on the center. Let's also hide the scale and select the faces that are on the inside to create a sort of indent on the cover. Hit delete the faces. Also delete the face that's on the mirror plane. And now select the vertices and make a new polygon. Hit P. For me, I have the shortcut on P key, so select all the four vertices that you want to create the polygons from and hit the P key. Okay. Now the cover is almost finished. Let's just select the top and bottom edges, and select edge and bevel edges. Let's just drop the tool and put there 2.5 millimeters. 2.5 centimeters. Okay, and the cover is finished. That looks pretty good. Now go to Shading tab, select one of the objects, hit F to frame the object to view, and let's rename the material to wood. Change the base color to brown, so we can see what object has which material assigned. Okay, let's hide the cover and unhide the scale, and let's create a new material. Let's call this metallic, and let's change the base color to gray. Zero out the saturation, not value. Value has to be something light gray, very light gray. Metallic to 1, roughness to something around 0.2. Now let's unhide the needle and the weight. So needle and the weight, and let's assign them the same metallic material. So select the weight, and from the drop down list select metallic, and now the same for the needle. Okay, now select the metronome body, and let's add here another material to slot 2. Let's click new one and rename it black plastic. Change the base color to black, and now in the edit mode, select hide the scale so we can see the entirety of the body, and select the faces that are on the inside of the indentation, and also the faces that are on the top pyramid, so, or top prism. Select them, the small ones, the rear ones as well, and also one more on the bottom, this. And now from the slot drop-down menu, select black plastic and click assign. This will assign the material to the selected faces. Now the materials are assigned. Return to object mode and let's unhide the scale. Now we will make a simple UV unwrap for the objects, but for that we will have to apply the mirror modifier so that it's not mirrored on the UVs. So let's apply it for the metronome body, and for the scale as well. Now select again one of the objects in the object mode and frame it. Now let's go to edit mode with the scale, select all the faces and select UV, Smart Project and click OK. This will make a simple unwrap. It's not perfect, but for this tutorial, it's more than good enough. Now let's do the same for the weight. So select the object, go to edit mode, select all the faces and the UV Smart Project. For the weight, let's scale down all the UVs and move them to the top right corner. No, but let's keep the proportions. Move them to the top right corner and now select the needle and again use the Smart UV project. So this, okay, and let's select the UV islands, rotate them with 90 degrees. And now scale them and position them a little bit. I want the left side of the texture to be devoted to the scale, because we will make their markings in Photoshop, or I'm using GIMP. So let's position the needle islands to something like this. Okay, back in the object mode. Now let's select actually the metronome body and now select all the polygons and again UV, Smart UV project. Okay. Now the most important thing here probably is that let's click to synchronize, and so we can see which faces we have here. Now let's select this front face and rotate it with 90 degrees. And the most important thing here for the texture will be that the sides of the metronome and the front face that we just moved to the top right corner is let's say on the same direction. So let's select the bottom. The bottom doesn't need to be that big, so let's select it and scale it down. This doesn't need that much space on the texture, so let's move it somewhere else. Now select the right side of the metronome, move it down so it looks like it's mirrored with the other side. Let's move the rear side out of the texture for the moment. Move the left side, just the left side, not the other islands, to the left of the UV map, and let's place the front panel in between the left and right side. And I think that I will not have enough space actually here. Okay, so what to do with it? Let's move the other islands somewhere out to the top right corner, and I think what I will do is actually I will mirror the right side and move it to the same spot as the left side. So click UV mirror on the x-axis and move it to the same spot as the other side. Okay, and now we have more than enough space. So let's move this somewhere here. And really here it doesn't matter that much how it's organized. We'll use a procedural texture for the wood material, but it has to at least flow decently. When we actually build the texture, we can adjust the UV islands. Now let's start building the shaders, and let's start with the black plastic. Now add a texture coordinate node and a mapping node. Let's connect the UV to the vector input. And now add a noise texture. Okay, so plug in again the vector to vector socket. And let's add a bump node. And a bevel node. We will use a shader level bevel instead of making the edge loops. Let's connect the vector to height and the normals to normal sockets. Now let's actually change the parameters. Obviously the noise texture is too large. Let's turn down the roughness to 0.33, 0.1 on distortion, and we will use the mapping node along with the scale of the noise to make it very small. Let's adjust the roughness a bit. And now let's crank the scale to 100 on the X and Y. That's a bit better. But let's also use the scale of the noise texture. And now let's turn down the strength to 0.5 and the distance to 0.1 millimeter. So it's very, very, very subtle. Okay. It seems too shiny, so let's increase the roughness to 0.3 and also turn the scale to 15, and I think the plastic is now finished. So let's switch to slot 1 for the wood and let's make the wood shader. Now again, add a texture coordinate node and a mapping node. Connect the UV to vector. Now add a noise texture and a wave texture. Connect the vector to vector sockets and add a math node and set it to multiply. So math, and change the mode to multiply. Connect the factors to the individual values and let's plug the value to the base color to see the result. I already made the shader, so I know what values to preset here. So I will just enter the values for the scale, detail, roughness, distortion. Just see what the result will be. Okay, the distortion will make the waves there in the noise texture, and we have to modify the wave texture, the scale to 1. Distortion will be pretty high, 23.5. Let's increase the details as well, the scale also. Now the detail roughness, let's modify it to 0.76 and the phase offset to 0.4. And now to make it look like a wood grain, we have to decrease the scale on the Y to 0.25 to make it look like it's prolonged. Okay, now I think it looks pretty decent, and also the UV mapping seems to look quite okay, so we don't have to modify it. Now let's add a color ramp, not a gradient, a color ramp to colorize the noise. I've downloaded wood texture from polyhaven.com. So let's actually open it, wood, and now on the color ramp, select the eyedropper tool and click and drag across the wood texture to gain a sample of the gradient. Now let's click one of the sliders to recompile the shader and let's see the result. And I think it's pretty decent as it is. If you don't like the result, click the eyedropper tool and drag it across the texture on a different spot. And I'm just adjusting few of the sliders to pop out some of the brighter colors. But I'm quite satisfied with it as it is. Duplicate the color ramp and reset it. Invert the color ramp or connect the multiply result to the input and invert the color ramp. And don't drag it all the way to the end. Just move it a little bit farther to pop out the contrast a bit. Add a bump node and connect the result of the gradient ramp to the height, and add also the bevel node and change the bevel radius to 2 millimeters. Okay, plug the normal sockets and also to the material input. Okay, now we have to obviously turn down the strength to something like 0.1 millimeters, and it is still to pronounce the effect. So let's turn down also the strength. It has to be just very, very subtle. And now it looks okay. Add another color ramp, and we will use this one to derive the roughness value of the material. Let's turn the blacks to a rough value, so almost to 1, and the other one to something lower, and plug in the roughness, and let's see what it will look like. Maybe it will be too shiny and we will have to modify the value. So let's rotate it around. Yes, I think that's too shiny. So let's modify the value for the second slider, increase the roughness a little bit to something around 0.3. Okay, so the wood shader I think is complete now. Yeah, it's not great, the UV mapping, but it's decent. Now I forgot about the cover, so let's unhide it, and we have to make a UV map for it as well. Hide the metronome needle and the weight, and go to UV editing. Now we have to go to object mode and apply the mirror modifier. Now back in the edit mode, select all the faces, UV, Smart UV project. Okay. Now let's look what it looks like, and we have to rotate the UV islands 90 degrees to have the same grain flow as the rest of the metronome body. So select actually all the faces on the right view. Now select the polygons on the left side, rotate it with 90 degrees, and move it somewhere so it fits into the square UV texture. Let's move it down, select the other side, rotate it with 90 degrees, minus 90 degrees, and align it, which will create us more space for the rest of the UV islands to position them. Now, okay, so let's see in the shading tab, and yes, that looks good. Now let's hide the cover, and unhide the rest of the objects, the needle and the weight. Now actually we will export the UV layout, so go to UV edit, select UV, export UV layout, and that will export the layout of the UVs to a PNG image. Let's name it Metronome Scale UV. And now I will actually speed up the video a bit because the making of the texture is quite a long process. So I imported the layout into a vector editor. I use Inkscape. I froze the image, added some lines to the center of the scale, and with a reference image opened on my second monitor, I started to write the etched texts that are on the scale. So this central plate reads the various tempos. And then I actually started to add the tempos measurements themselves. It's actually on both sides of the scale, and it increases from the slowest tempos. It increases with 2 BPMs, and then it goes with 3 BPMs, 4 BPMs, and then finally at the increases are with 8 BPMs at the fastest tempos. So I played around with it until I got it pretty right. Then I exported the image as a PNG and imported it into a photo editor into GIMP. I placed it actually on the UV layout and added a white layer and put it below the text itself. Now back in Blender, let's add let's close the wood texture and add a texture coordinate node. Now add a image texture. Let's connect the UV to our vector and open the texture itself. So now let's plug the color into the base color so we can actually see it. And now we don't see anything. Let's go to UV edit because I think the UVs that we used are actually on the back side. Let's synchronize the view and select these two faces. Yes, these are on the back side. So let's just select them and move the UV island to the same spot as the back faces. Now actually we should be able to see the markings. Okay, now add a brightness contrast node to make it more contrasty. Add a bump node. Now plug the brightness contrast to the height, turn down the strength to 0.25 and the distance to 0.1 millimeter or 0.2 millimeters. It has to be just very subtle. Now plug the normal to the normal socket of the material, and now we have it etched on the scale. Okay, now add a color ramp. We will use this for the roughness. The black parts will be rough, so let's turn the black to white, or the position 0 to white, and move the right slider almost to the left side and turn it. This is the metallic part, and let's turn it to 0.2. Now plug in the color to the roughness, and the brightness contrast plug directly to the metallic socket. So this is the material for the scale. Now actually one more thing, let's select the metronome body, and here the bevel radius is correct, but I think I forgot it to set it at for the plastic material. So let's actually see what it looks like. Let's switch the render engine to cycles and to GPU compute, and switched our view to rendered view. Take a moment and turn down the samples for the preview to 16 and render samples to 64. Now let's actually fix the radius because that creates a weird shape. And now at 2 millimeters, that's correct. Now let's actually finish the metronome. Let's go to Layout tab, add a cube, scale it down to 1 centimeter on all the axes. So it's cube, 1 centimeter cube. Now let's position it on the z-axis to minus 5 millimeters. Let's move it on the y-axis to 0.55, and let's actually name this food. Now let's take a look. We have to also position it on the x-axis. It will be the same as the y-axis, 0.055 55 millimeters. Yes. Now let's select the bottom face, taper it, and back in the object mode. Let's actually assign it to object mode, assign it the wood material. We don't have to play around with the UV mapping because the cube has a default UV coordinates. Now hit Ctrl D, duplicate it, and set the position to minus 0.055 on the y-axis. Now duplicate it again, zero out the y coordinates, and put the x to minus 0.055. Now let's actually parent the foot to the metronome body, so all 3 feet. And now add another mesh, add a plane. This will be our backdrop. Go to edit mode and add some loop cuts. Now move the far edge to the top and bring it closer to the metronome on the x-axis. Now add 2 more loop cuts to make the radius tighter, and add a few more loop cuts to the edges so the corners look pretty sharp. It won't be visible on the camera, but I do it anyway. Now back in object mode, let's actually place it on the z-axis. So let's switch to the side view and move it downwards on the z-axis until it is flat with the bottom of the feet. Okay, now set it shade smooth and add a subdivision surface modifier. Now let's actually position the camera. So switch to camera, and in view align the camera to view so we can actually manipulate it. Select one of the objects and hit F to frame it, and now rotate the camera to position it until you like it. Select the metronome cover and let's actually detach it from the body, move it somewhere to the side and rotate it. I will put it on the backdrop plane so that it looks like it's lying next to the metronome. So let's rotate it on the y-axis, move it down on the z-axis, and also rotate it on the z-axis, and I will leave it like this, like it looks like it's below the metronome. Now go to Shading tab, switch to Camera View. I will actually select the backplane, name this, assign it a backdrop material, turn down the roughness a little bit, and like that. And let's actually rename this to a backdrop. And now in the World tab, let's assign a environment texture. I downloaded one from Polyhaven. So let's use this as our HDRI lighting. Now let's actually position the camera again. So in the view, let's align the camera to view to be able to manipulate with the camera. Now zoom it a little bit closer. Now in the renderer, don't forget to enable motion blur because that will keep the sense of motion even with a still image. Now select some frame where you like the position of the needle, and now we can now I will render the image to see what it looks like. So wait until all the samples are processed. And this is the final image, and I quite like it. And that's a wrap for today. Thank you for watching. If you like the content I'm creating, hit that subscribe button to get notified when I release a new video. See you at our next project.